determine the number of bits, that means the number of set bits in a particular number. Okay, so for this we are going to write to count the number of set bits in a given number. What is mean by set bit? Set bit means 1, clear bit means 0. Okay, so if I am having a given number, suppose my number is going to be integer num equal to 8. So I am going to write here. So suppose my number is 8. So what is its equivalent binary number? It is going to be equal to 1,000,000. Okay, so how many number of set bits are there in this particular number? The number of set bit is 1. That means how many number of ones are there in that particular binary number? So what is that? The count is going to be equal to 1. So this is the logic what we are going to find. Suppose if my number is 7, what is its binary equivalent? It is going to be 0,111. So how many number of set bits are there? Totally 3 bits are there. So what is the count here? The count is going to be equal to 3. So this is the logic what we are going to find out. Okay, so first we will see the logic, then later on we are going to write the program for that. Okay, so I think all of you understood about this, so we'll see the logic first. Okay, so how to determine the number of bits? Already in the previous videos I represented how to represent a binary number for a particular given number. So if you have not seen the previous videos, you just see the playlist. On the first video I have given in detail explanation how to represent the binary representation of any given number. So I am going to have number 8. Let it take. Okay, so the number is going to be 8. So how to get the binary equivalent representation for this? So I have to divide with 2. So 2 fourths and the remaining is 0, and 4 is going to be divided by 2 2s are 4 and the remainder is going to be 0. And how many times 2 is going to become here? 2 ones 2 and the remainder is going to be 0 here. So whatever the representation I am going to get here, this binary representation, we have to start from this last bit and we have to go in this representation. So what is its binary representation number now? So number equal to 8 and its equivalent binary representation is 1,000,000. Okay, so now I want to get whether it is going to be how we are going to determine the number of set bits are there in a particular given number. So for that what I am going to do, I am going to take a mask. So the mask is going to be represented by 1 left shifted by I times. So already we know that integer size is going to be 4 bytes. That is nothing but 32 bits. Is it right? So integer is going to be represented. What is the size of the integer? It is going to be 4 bytes. That is going to be represented with how many bits? 32 bits. So I am going to left shift this 1. How many number of times? 31 times. That means even though it is a 32-bit number, but the positions are started from what? The position is going to be started from 0. And what is the most significant position? The most significant position is going to be 31. So 31, 30, 31, 30, 29 and so on up to 10. So this is the representation what we are going to have for the binary representation. So here 8 is going to be represented by what? The binary number is 1,000,000. This is only 4 bits. What about the remaining 28 bits? So this remaining 28 bits are occupied with what? Zeros. So in the short form I am going to write this as, all of you see here, this is very important. So the number 8 is going to be represented with, okay, so 1 2 3 4 5 6 7 8. So 1 2 3 4 5 6 7 8, and I'm not getting enough space over there, so I'm going to write here 1 2 3 4 5 6 7 8. So this is 8 bits, This is 8 bits, 16 bits. This is 24 bits, and 1, 2, 3, 4, 1, 4 zeros. So this is the 32-bit representation for number 8. So this is what 32 bits for an unsigned int. Okay. So now what I am going to do, I am going to shift the 1. I am going to take 1. I am going to take 1 and I am going to check and operation. 1 is going to be shifted 31 times and I am going to check with this 0. So whether it is going to be 1 or not. So if 0 and with 1 is what? 0. Again I am going to left shift it again. So the 1 is going to be come over here, and again 0 and with 1 is what? 0. So again I am going to left shift it again. So 0. So 0 and with 1 is what? Again 0. So like that I am keep on shifting this left shift. So I am going to shift this 1 from 31 bit position. This is 31st bit position to 0th position. I am going on keep on checking, and wherever I am going to get uh, 0, that means there is no uh, set bit. Wherever there is 1, so suppose if 1 is going to become here, if I am doing under operation, 1 and with 1 is what? 1. So that means there, it means that there is a set bit is going to be present. So by looking over at this number, so we can come to know that there is only one set bit present in the number 8. So therefore the count is going to be equal to 1. I think all of you clear about this. So we will write the logic right now. Okay, fine. So if you are going to have any doubts, please comment on this chat box so that I can even reply it. Okay. So I am going to write the program right now. So what is the number I am going to take in? Int num equal to 8. So I have taken int number equal to 8. So and I am going to take, mostly in bitwise operation, prefer for unsigned int, that is a positive numbers. Okay. And I'm going to take int mask is equal to 1 left shift with I times, and I'm going to run the loop for I equal to 31. So I'm going to represent, okay, let it be take okay, here only I will write int I equal to 31, I greater than or equal to 0, I minus minus. That means I value is going to keep on decrementing. Okay, so if int I am going to take over here, and int mask, and there is no need of shifting him. If x, if x my value or my value is num now, so I am going to take num and operation, bitwise and operation with 1 left shift with I. So already I have taken it as mask, so therefore I am writing mask. If num and with mask should be what? Not equal to 0. Is it right? That means it should be a finite number. So not equal to 0, then only the count value. So initially I will make int count equal to 0. So then what it has to be done? The count value is going to be incremented whenever that particular number and with 1 left shift with I. So first I value is going to be equal to what? 31. So 1 is going to be shifted by 31 times. So the most significant bit is it is going to check first. So it is going to be checking first what? Most significant bit. So suppose I am going to have all zeros for 8s. So first one will come here. So 0 and with 1 is 0, and again 0 and with 1 is 0, 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 0 and 1 and with 1 is 0, 0 and with 1 is 0, 0 and with 1 is 0, so that all zeros only I am getting. I am not at all getting any finite value, that is one value I am not getting. So you can, I am writing that if it is not equal to 0, then the count value, if it is equal to 0, then the count value should not be increased. If it not equal to 0 means what? It is equal to 1, then the count value can be increased. Okay, so that's what I am writing here. If num and with mask is going to be not equal to 0, then that means indirectly it is 1. Okay, then the count value is going to be incremented. Okay, so I am written this logic here. And finally, printf, the result is count. Okay, so finally I have written this result. And yeah, as I am given the return type as int, I am writing this one, return 0. So I will just visualize this execution, uh, and I am getting the error hash include stdio. Sorry, I have written it as studio. Okay, so I am getting the logic over here. If you keep on observe, so this is going to be present in stack segment. So all the data, whatever the variables it is there, it is present inside the function, so that all the variables are present in stack segment. So as I am not dynamically allocated any memory, so there is no heap segment over here, and I am going to close over here. And conditional jump depending upon the value stopped, so there is some error going to be there. Okay, we'll check that what is that error. If I will edit the code. uh, okay, if num and with mask, okay, let it me take like this. Then if num and with mask, so that is a finite value, then the count value is going to be incremented. Yeah, there is no need of two parentheses also over here. mm-hmm. Mask is one left shift with I. Okay, what I got this, if num and with one left shift with I, so that is 31, I greater than or equal to 0. What is the conditional depends on uninitialized values. So uninitialized value, conditional jump, count plus plus. Okay, uh, can I write like this then? Okay, if num and with 1 less than I not equal to 0, let it write like this, and we will check. So I'm not going to use mask over here, directly execution I have written like this here. So the I value, if you keep on check this, and okay, so if you keep on checking the value, the I value is keep on decrementing. See, if you can observe the I value over here, the I value keep on decrementing, 28, 27, 26. So the count value is 0 only. So the loop is going on incrementing. Only whenever that particular bit is going to be equal to 1, then only the count value is going to be incremented. Okay, so I equal to 6, 5, 4, 3. So see this, the third position. So whenever I equal to 3, then only the count value has been incremented. Okay, I equal to 2, count is 1, I equal to 1, count equal, I equal to 0, count equal to 1 only. So it will comes out of the for loop, and it will print the value as the result is 1. Is it clear? So this is the way how we can able to identify how many number of set bits are there in a particular given number. And the only thing here, I have not used the mask. I just remove this. Okay, So this is the process. Okay, I think all of you clear with this. Thank you. And if you like this channel, please subscribe and share it with your friends also. Thank you.